thank you for coming to the first rodeo. This is a community building event, and so your object for today is to talk to someone you have not talked to before. I don't care if it's a hi or I like your shoes or whatever, you should do that and make a friend. But the friend part isn't required. But the talking is. First off, we have Plasma Pip giving us a lecture on GLSO.
I guess I'll get started. We have, trying to think.
Do you want my seat?
I'm okay here, don't worry. Hi, I'm Plasma. I've been doing visuals for a couple of years now, so it's not quite my first rodeo doing visuals. However, a lot of the programs I've used in the past have been very more high level, like Max MSP. I've dabbled a little bit with Touch Designer, but I haven't really done much with the code side of visuals, like more live coding. So what I'm showing here, let me get the frog.
Frog's important.
What I'm showing here is some live rendered GLSL shaders, or just one shader, in a language called GLSL. And I wanted to first learn how to make something like this, and then try to break down how does this actually work. So I'm going to try to do that in about 20 minutes or something. And yeah, so we'll go from there. So first I need to over here. Alright, I might think for a second. It's thinking. Okay, there we go. So GLSL stands for OpenGL shading language. OpenGL is a framework for making just computer graphics in general. And then the shading part, I think most of it already runs on the GPU, but basically all of this is happening very fast because it's happening on your GPU processor, which is built to compute many numbers at once. There's going to be a couple of references I'm going to be mentioning, but...
We get the slides afterwards.
So, yes, I need to... Yeah, I can do that. So, the code that I made is available on my website, and also all of the links that I might reference are also going to be up there, as well as an interact. You can play with the shader on there as well. So don't worry about writing down links or URLs, and I'll try to upload the slides as well. It's going to be a bit of a work in progress, but yeah. This is the start of a GLSL shader. We have just a black screen right now and some code. There's a few things happening. We have this function that's called void main. That's just the main function. And then we have this one line of code that says gl_fragcore equals this vec4, which stands for a vector, a 4-dimensional vector. And those 4 elements are the RGB values of the screen, so red, green, blue. The last one is an alpha channel, which is of how the opacity of the image, which can be relevant if you start stacking images on top of each other. And right now the RGB values are all set to 0, so because everything each pixel on the screen has no value, it's just black. And this GL frag color refers to a GL concept called a fragment shader, which is how computers generate graphics. So this is telling the computer what should you display on the screen for every pixel, while it goes to this variable and looks to see what's the color of each pixel. But we don't want just a black screen, so let's see what we can do with it. One thing that we can do is values of the coordinate system. So some extra things got added here. At the top, there's some like global variables we can play with, like the software knows, for example, like the frag chord, which is like the coordinate points on the screen, so it knows like how to tell like what is this point versus what's that point over there. It also knows the resolution they're working at. It's also keeping track of the time, which is something that's interesting if you want to make things move. But one thing we can do is like normalize all the pixels on the screen to be like arranged from 0 to 1, and that's called like a UV map. You may have heard like a UV map before when like doing texture generation or something like that. But those, it's essentially like a unit vector for your screen, where your U is like the y-axis from 0 to 1, and then the V is the x-axis from 0 to 1. And we can plug in those values into our little frag color matrix. So we have the x values going into the R channel, so red. And as we can see, as you go from x equals 0 to x equals whatever my screen resolution is, but we're getting more red in each pixel. Likewise for blue, as we go up in Y, and then at the top corner it starts mixing the two colors. So this is how we can start thinking about like how to add color onto a screen. So one thing when I was like making the shader, I wanted to like make a spiral. That was my thing. So how do you like take this concept of like, well, we have different axes, and how do we draw a spiral? So we need to start thinking about like, how do you draw things? How do you like position stuff? Because right now one thing that's interesting is that it thinks the origin is set to this bottom left corner here. That is like pixel 0, 0. We want to draw something in the center. So we need to like somehow transform our UV coordinate system to the center of the screen. And we can do that with a bit of code here, basically saying that, well, I want to, like, I know that the bottom value there is 0, and over here is 1. You can do some little math tricks to essentially readjust your 0 point to be at the center of the screen, and now your kind of like coordinate references are going from like -1 to 1, with 0 at the center. That's helpful if you want to start like drawing some circles or something. And you can also like, after you do these kind of transformations, yeah, this is like the 0 to 1, or -1 to 1 positions now that we can reference when like trying to draw things. If we want to draw like circles, one thing that is very helpful is to maybe not use Cartesian coordinates, but rather polar coordinates. And the difference between those is like the Cartesian coordinate is like x and y, but you can also redefine your coordinate system to be in terms of like a length and an angle. And that's kind of quickly depicted here. So like the way that you can move around on the screen originally is by choosing an x and y value. You can also get around by choosing a r value, which is like the length of some like vector, and then a theta value, which is the angle of that. And you can still get to any point through that. And you can jump between these two coordinate systems by some like transformations that use sine and cosine. But that's what you'll find is that it's a lot easier to generate things like circles when you are using this coordinate system, because you just keep your r value constant and you just rotate your theta. Now the rest of this is going to be easier to show in code. So I'm going to jump over to the actual code here. Here. Alright. And then I think I want need to remember. Yeah, so this is the same code, but I've added a few things now. And what I've done is that, so before we were looking at, this is the part we were looking at, we had our UV map and we transformed it to be at the center of the screen. And then I have this, this line of code that's using a function that I made called spiral wave. Well, what is that? Well, you can define functions as needed as you are writing GLSL code. So this function takes in like a coordinate system and some other variables and is calculating its r and theta value, which is those like the direction of that like vector as well as its angle. And there's some extra code here that I will leave for now, but the one thing I'm plotting is this line here. Is basically, I guess I could just plot R, now that I think about it. Yeah, it's the same thing, but I'm plotting this R value and I'm plugging that output into the green channel. So we already defined our red and blue channel, but now I'm putting in this circle that gets generated in the green channel. So this is going to be the one we're playing with now. And for simplicity, it might actually just get rid of the other channels and just make it black and white just to have a little less activity. The one thing is like we want to generate some spirals. Well, one thing we could do is put this like radius basically. You can think of it as a radius at this point. You can plug that into a sine function, and then maybe also add that time variable. And now you have a circle that's moving. So now we got some motion. That's cool. That's kind of going slow. Maybe we want to make the radius of that circle a different size. So now, okay, this is a little more interesting. And then, so we have some circles here. How do we go about making it more of like a spiral? Well, right now we're only playing with the radius, but we also have that like theta aspect. So we can alter the pixels on the screen based on different angles. So one thing we could do is we could add, based on like the angle of the screen, what's the radius of that circle? And that's going to be this line of code here. And what it will do is that I just added a little bit, but it's like as it's rotating around the screen, it's adding the angle that it's at to the radius of the circle, and now they're no longer meeting up with each other. We can add a little more, and yeah, just that. We add a little more, then we get a proper spiral there. And there's some fun tricks when we kind of put everything in a sine function, because if you just put more, or you can just multiply things together, and then you get more spirals. So now we have kind of this fun little spiral effect. When I was making this, I wanted to get a slightly different effect. So there's a different way that you can define like the curve of the spiral by using like the golden ratio, basically. And that involves using some log functions. And I followed a very similar line of code there to get like this slightly different spiral instead, which I liked more, I guess. So now we have this like fun little moving spiral thing. And then I only have one screen, so you'll have to also bear with me as I look at my notes. So, okay. So then, well, this is fun, but we want to make things like a little more interesting. So we can add some extra code here. There's some fun things we can do, like we can try to. At this point, like when you start playing with code, it's okay to just try different functions and plug in different variables and see what works and what doesn't. There is really no wrong answer with this stuff. As long as it runs, it's working. So after some experimentation, let's see. I'm gonna have to plot it like, that's wrong. So I didn't do this in the most optimal way, but after some playing around, I was able to like invert the image halfway through. That's neat. I'm gonna just quickly rewrite some code here. Another thing that's nice about GLSL is that you can live compile it, so like I can edit the code and it auto-generates the result in real time. We can also do some other things to essentially create the same effect, but now it's like there's inversion happening at different angles. That's pretty cool. Then there's a lot of different functions that are available in GLSL. One of them is called this like frap function, or frog if you prefer. But basically what it does is if you like have a value that's like continuously increasing, it will like chop it off and reset it, so you get sort of like a sawtooth effect. And it can be fun to apply that to images, because then you can get every time where it like tries to make a step, it'll instead have a ramp, and you get all these extra lines basically that happen in between the spaces they were having color. And this can be a fun way of just adding a bunch of visual information. So this is all neat and interesting. One thing is like one effect that's very common in visuals also is to have feedback in some way. But like how does the computer implement feedback though? How does that actually work? So get this. Alright, so it's the same code, but I add some extra lines. So to do feedback, you need to know like what the previous frame was, because that's the back part of feedback. And fortunately, in this particular, right now I'm using like a GLSL compiler called the Force, which is nice because it auto-compiles in real time, but it also has some nice little functions. So there's one function called just back buffer that already saves the previous frame of data. And that's like, that frame is basically just the frag color variable from like the last frame. So you can plug that into a texture object and then apply a new coordinate system to it. And then this is where you can start altering what the feedback is doing. So here I have this like the UV space, so like just the unit vectors of like which points are where. But then I'm adding just a small value in the X direction. And this is what's causing the image to go to the left, for example. You can also do the same in the vertical direction or stuff like that. And you can get different kinds of effects. To actually get the feedback though, you need to like blend the current frame with the previous. And by doing that in an iterative fashion, that's how you get these like trailing effects, and you can alter how much of that blending is happening to get different degrees of feedback and blending. So whenever like the basic mode of feedback in a lot of the visual softwares that are available is just like an averaging of these 2 frames. By doing that over and over again, you get the pattern of many frames over time.
Why did it turn yellow? Didn't you just change the feedback or the spacing or whatever?
Yeah, I
Did you
also
I think I just missed it.
yeah, I have this line here of I wanted to try to like visualize or distinguish the different layers of the feedback.
Oh.
So every time that it performs a feedback loop, it adds a bit of color into it. I could turn that off, but it ended up kind of being hard to see. That's if like you don't have any kind of tweaks. But that, I guess, if it's some sort of like a medium value, that's something I could probably tweak a little more. But you can apply filters every time it does this like little feedback iteration, which is where there can be a lot of interesting things that happen. So this is cool. Since we have the spiral thing going on, I wanted to try to like have the feedback not going in just like down or sideways. I wanted to have it be like a rotation. And that one's a bit more difficult to do because you need to now rotate the image. To do that, there's some tricks in linear algebra which you don't need to know all the details of. Basically, if you multiply the whole image, which is just a matrix, by another matrix, you can do these kind of like linear transformations. One of those transformations is this other function that got magically added when I was copying and pasting things. But it's just a rotation function. And all it's doing is that you feed in like an angle, and it has this matrix where it uses some sines and cosines. I won't go into the details there, but there's a wiki page that kind of explains like what it's doing and why it works. But this is something that we can apply to the system. So let's say I start trying to do that. No, that's flashing. We do this. That might flash a little bit, but basically, what's happening is I'll have to do this. It's not happy with me. Let's try to debug. This thing actually has a debug mode, which is quite helpful. Is not defined. What's going on? What did I do wrong? Oh, that's what it is. GLSL is based on C++, which is a very finicky coding language where you need to tell the code what every variable should be. So I forgot to tell it that this new matrix space is a 2x2 like vector. But you can multiply like the coordinate space by this rotate function, and we start getting this rotation effect, which is close, but it's rotating about that 0, 0 point. If you look, it's like rotating like that. And we want to rotate about the center. One trick that we can do to get around that is to like temporarily move ourselves from that bottom corner to the middle, do the rotation, and then go back to the corner. That's one thing that is like, we can do that because the linear part of linear algebra means that everything's like reversible. So that's one thing why all the weird things in linear algebra math can sometimes be helpful. And after doing that, oh, I know why it's not working. There. Once we do that, we're able to start rotating about the center. And I think my resolution might be a bit low. Just that. So now we're getting kind of like a more uniform feedback where it's kind of all feedbacking in the theta direction now. We start thinking of it in polar coordinates. So, again, some interesting things here. And to kind of close things off, we can apply, where is it? Here. Yeah, so we can apply another like frac function, so like that like staircasing effect to get like even more kind of levels of detail into the image. This was kind of just me playing around and trying different functions to see kind of what looked interesting or not. And now we have like, we've built up this like rather complicated visual effect where it's relying on that initial spiral with some like extra detail added with that first layer of that like staircasing fract effect. We applied some feedback in the theta direction, and then I've done some extra filtering on top to get this. And just to kind of, one thing that's fun is that these one of the extra variables that the code takes in by default is actually the mouse position, which is rather interesting. So I have this like final bit of code at the bottom that says like to render different parts of the shader chain at different parts of the screen based on where my mouse is. So here we can see that like initial effect that we started with, where we just have that spiral. Here's that staircasing effect on the right. Then we started applying the feedback. There you can sort of see really just where it's pulling the feedback from and it's rotating around. And then if we apply that final layer of like extra staircasing and color effects, we're left with the final effect there. So yeah, and you can like really just add even more and more complexity onto this. There are different functions I still haven't learned myself. But all of it is thinking about how do you like color all the pixels on the screen, and like sometimes you want to do round things, working in just XY coordinates might not be as sufficient of working in a different coordinate system like R and theta. Yeah, that's I guess a mini introduction to some of the like there's one thing of like, well, where do you actually use this, right? Because there's yeah, because like nowadays there's a lot of really cool software out there for like between Touch Designer, like VDMX, Max MSP, all these different like visual softwares, Bresloom, that's missing that one. Why do you need to like go and deal with all this code stuff? Well, sometimes it's advantageous to have like a very, so this is compiling in real time, right? Like it's tracking my mouse positions, doing all this live. That's very helpful for like audio reactive work and stuff like that. It's also helpful if you have something where you want to have, let's say, if you want to generate a lot of images in sequence or repetition. So this is an effect that I used at a past project I was working on. it's not. There we go. Just having some trouble getting to the right mode. Is that? Yeah, there we go. Whoa. Good. Just a few of those. There we go. So now I'm in a completely different program. This is Max MSP, which is something that's like, it's like Touch Designer, but basically now I have a whole bunch of these like small spirals, and I'm generating these with GLSL code. And the thing that's nice about it is that I can generate thousands of these, and GLSL is super efficient. So in theory, I could actually control all of these individually, and I'd still be able to run on my laptop. So this is kind of one area where even if you have like a high level like graphics tool, it can be nice to have like one kind of unit generator, like a visual generator, to make simple effects that you can alter in real time. And I think these actually work. Maybe it actually doesn't. I can generate more. So that's like 200 of them. I had a way to like change the speed of them and stuff like that. Yeah, they're struggling. There's also a physics engine happening in here, but yeah, so that's like one area where like sometimes it is nice to know like how do you efficiently generate a spiral that you can edit in real time. GLSL is like an interesting tool to accomplish that. You can plug that into different areas like Max MSP. I think Resolume also has like a direct code input.
Touch Designer.
Touch Designer.
I
Yes.
think you could put this in game engines. Could you? I think maybe like Unity, Unreal.
Yeah.
Or run into game engines and stuff like that.
Definitely Unity, because one thing that one detail that's interesting with all of this, going back to the code, is that the resolution is in 3D. You actually have X, Y, and Z resolution. So OpenGL is by default in 3D. So that extends itself very well to stuff like game engines. In theory, like, well, if for those who have played with Shader Toy and stuff like that, there are a lot of like 3D shaders that are out there where you can generate some very crazy stuff. But yeah, it does definitely extend to a lot of that. I think that's how like Minecraft shaders work, basically. So, yeah. Thanks. The code again is available on my website. Play with it, edit it, go wild. Because I don't know, a lot of this like making stuff. I mean, I'm sure y'all are like playing around with visuals and music too, but you just have to like start somewhere, you know, play around.
Thank you so much.
Thank you.
Yeah.
5% everyone.
What would it take to crash it?
1,000. I'm trying to. You can definitely crash it. Oh, like you can have. If you plug like two feedback loops into each other and make like an infinite chain, that would do it.
Oh, I'm so sorry. I didn't know.
Just too many frames. The FPS would go so high that it couldn't keep up with the amount of frames.
I also like how they're looking here, like the
Yeah,
frame,
the fan.
frame rate.
Yes.
It's crazy. Yeah.
Yeah, so I was inspired by the lecture earlier, so I'm going to tell you guys a bit about my setup. This is a synthesizer, and this is like a piano-like keyboard. Synthesizer, I can like model sounds and like have it do the same thing over and over again. So like that's like the first thing you heard. It was just like playing the same note over and over again. And yeah, I think. Well, I guess I should back up and say like. I think the reason why I like to make music is like it's like a good back crack. Like all of the fascia and like stiffness in my body after like bad days at work or like being up on your feet, it kind of melts away when I make music. So if you feel like you want to like stretch or move around, yeah, that's like, I think that's where my music comes from. The sense of like relief, like release and relief of tension. So yeah, but I'm only one person, and ideally I'd like to like make a whole band's worth of music, but I only have my own two hands. So like, this thing plays stuff for me, and this thing I play more actively, but I route this thing through my computer so that it can play itself. And same thing with the violin. And you might have seen me trying to step on these colored tiles. Each one of those is a loop. So unfortunately, it's not super synced up with like, what I'm playing. So I have to be mindful about like what I put into here. Sometimes it might be like too jittery or something. So yeah, that's a little bit about how I'm making this music. How much time did I just use?
I think like 20 minutes.
Okay.
Yeah.
So maybe I'll do one more.
Okay.
So I think the idea for this song came from when I was at home with family. Recently my grandfather passed away, and there was this big event where all of my extended family came from across the country to come like stay with my grandfather in the hospital. And I began playing this like loop on the piano, and it was a really calming loop in the throes of a lot of the like happenings during that time. And there's this cool thing I learned in the hospital. When someone is on their final days, there's 1 or 2 days where if they were in like a previously kind of like comatose state, they become like full of energy. Like their body gives them like adrenaline or like a rush that kind of gives them like this alive like sense, as if they're cured of their disease. And I also learned that hearing is kind of like the last thing to go. Yeah, I had this thought of making this piece of music start slowly, build to some kind of like electricity explosion, and then like end with some calm. Yeah, so we'll see how it goes.
Thanks, Kevin.
Give it up for Kevin, everyone.
I'm Scobi Leah. I'm gonna be doing a skit. It'll only be like 3 minutes long.
Do you want visuals?
Sure. Yeah. Yeah, it's one of my favorite YouTube videos. Well, man goes crazy, rips off shirt during street interview. And it's like
Let me tell you my name. I'm confused.
but I basically memorized this whole thing, and I'm yeah, I haven't like memorized lines since like high school, so this will be my first time like performing words in front of people in like many years. Yeah, it'll be shocking and uncomfortable.
What's your name?
My name? Let me tell you my name. I'm confused. Because, you know, we're supposed to believe in the ministry, right? We're supposed to, the church and state are supposed to be separate. I'm confused because I never went to school. Does a confused person get a resolution? I don't understand. You see, when you go like this, right? You have a cross, 2 sticks. And that's how I felt when I was in Waterloo. Because when I walked in Waterloo and smiled at people, they treated me like a vampire. They used a cross and they went like this by not smiling at me. In Toronto, hey, hi guys, Steve Spiros, easygoing. Those who know me, I'm a nobody. And you understand? You can't kill a person with no body. So, why am I afraid?
I'm not afraid. I'm afraid of the boogeyman. Who's the boogeyman? You figure it out. I'm getting out of here. I'm going back to Waterloo, where the vampires hang out. And I'm going to wear my sunglasses at night. You know why? Because women show their tits, wear short skirts,
And then they feel violated when I look at them. Why? Because I have sunglasses on and I'm weird. I'm from Humberside. I'm sorry if I made a fool out of Humberside. All these people who called me a sleepwalker, I woke up. Now I'm back to sleep. Because I'm going to be committed in an isolation room. Because I'm going to go back to the ministry to allow them to perceive me as I am. A fuck up. Goodbye. Hey Toronto. Look at this square. It was a shithole when I worked here. Now it looks like New York, Manhattan. Where are the bums? There's no bums here. Toronto doesn't have bums. But Waterloo, they're creating bums. They created me. Why? I don't know. Maybe it's the church. Ask the Pope. He knows everything. I've had it. I'm gonna die. How can you die when you're dead? Oh, wait a second. I'm gonna be crucified, right? I'm not gonna raise my voice because I'm committed to the Lord. I love you. Thank you.
Give it up for Scobi Leah.